As we did with the rest of the modules, we are now checking the local hardware configuration prior to testing. We will use this module to test zone ranges and trip times of the distance protection function. Voltages and currents are required to generate impedances. Therefore, the currents and voltages in all three phases and the trip signal will be enabled for this test. The Advanced Distance module comes with the same well-known views from other modules. The impedance plane captures and displays the zones defined in the test object. It is of particular relevance when it comes to performing the tests. Additionally, Advanced Distance includes the impedance time diagram, which displays the trip time of a relay as a function of the impedance in the real imaginary plane. The test view is composed of 5 tabs. The first 3 tabs, Shot, Check, and Search Tests, are different modes of testing. The last 2 tabs are part of the preparatory steps to ensure a successful test. The Trigger tab is used to set the trigger conditions of the binary inputs to which the relay contacts are connected. Our trigger will be the trip contact that we enabled in the local hardware configuration. On the Settings tab, there are 3 simulation models available in the drop-down menu: constant test current, constant test voltage, and constant source impedance. Constant test current should be selected when testing distance protection relays with a current pickup setting. This way, the test current is set to the specified value and the relay voltage is calculated using the defined fault impedance of the test point. The pickup value for the relay under test is 1.8 amps. Therefore, 2 amps is suitable in this case. For test points with a higher impedance than those corresponding to the nominal voltage, the test voltage can be raised up to the maximum value indicated in the Vmax field. For testing above this limit, either manually reduce the test current or apply the automatic adaptation of test quantities. This poses the risk of preventing the relay from tripping when the test current does not reach the pickup value. In the Fault Inception section, the phase angle of the voltage can be specified. We select Random to approach more realistic conditions. There is also the option to add a DC offset transient behavior. The load current setting is meant to verify the exceptional behavior of certain relays that react differently if there is current present during pre-fault. As this is unknown for the relay under test, there is no need to activate this option. Each test shot consists of 3 states: pre-fault, fault, and post-fault. The time for each state can be set in the Time section. As in the overcurrent module, the reference for the time measurement can be set to the fault inception or the pickup of the starting contact. Activating the extended zones makes these zones available for testing and will be displayed in the impedance plane. Of course, the relevant zones must be defined as extended zones in the Zone Management dialog box in the test object. The switch off at zero crossing causes the CMC test device to disconnect the currents after tripping in the corresponding natural zero crossing. The accuracy of the search test is determined through the search resolution fields. The larger resolution of either the absolute or the relative search resolution is applied. The search for the actual reach impedance stops when the difference in impedance between 2 consecutive shots is less than the given search resolution. If the characteristic is unknown, check the Ignore Nominal Characteristics option. In this case, the algorithm changes and the shots are placed at fixed search interval distances throughout the search line.